Hey guys, welcome to my video on graphing polynomials. And before I would like to graph polynomials, I would like to go over some vocabulary that you need to know um, so that you can better understand how to do this. Okay, so let's begin. So the first thing I would like to bring up is what's called end behavior. All right, so end behavior is the description of the values of the function as x approaches negative infinity, which is the left side of the graph, or as it approaches positive infinity, which is the right side of the graph. Okay, so let's start with simple examples first. So let's take a look at f of x equals x squared, which is a graph that you know and very familiar with. And I just want to point out what end behavior means. So end behaviors, we're looking at kind of like the endpoints of the graph, like where does it start and then where does it end, right? So like this is on the left side of the graph, and then this is where it ends on the right side of the graph. All right, so that's what end behavior. So let's compare that with x to the fourth power. So as you notice, I'm just showing you how to identify the end behaviors first. Okay, so this is what they're talking about: end behavior on the left side, end behavior on the right side. Okay, that's for x squared. Let's change colors. Let's do end behavior for the left side. This is what they're looking for, and end behavior to the right side. Okay, and I think you get what I'm saying here, but let me just give you a second example, a third example, just in case. So I'm going to compare with x to the sixth power. Okay, so now x to the sixth power, they're talking about this end behavior right here and this end behavior right here. And the question is like, where is it going from the left side and where is it going as it approaches the right side? Okay. Now let's investigate different powers. So right now I have compared an even power, even power, even power. And now let's compare an odd power. Okay, so this is f of x is equal to x, which is linear, and it's being raised to the odd power of 1. So again, what they're asking for is end behavior right here, and this is an end behavior as well. Okay, notice how they are going in different directions. Here, x to the third power is a cubic function, and again, this is the end behavior they're looking for. Okay, also again, they're going in different directions. And then again, I am going to show you x to the fifth power, which is this purple right here. So again, this is what this is what they're asking for. That is the definition of end behavior. Those kind of like endpoints or arrow marks. Where does it start, and then how does it end? Okay. Okay, so as you notice here, there are certain things that are common between odd and even, right? So these are all even. And as you notice, even degrees or even exponents create end behaviors that end up to be the same, right? So like they're all pointing up. And then odd, right? So odd degrees are pointing in different directions. One is going down, it's decreasing, and then one is going up and it's increasing. Okay, and so we've made a little chart for you to identify uh, how to describe the end behavior of any polynomial. All right. So let's just quickly run through these graphs that I have here for you. So again, if I were to describe the end behavior here, this is increasing, and if I were to describe the end behavior here, this is decreasing. So this is more likely an odd degree, right? Because it resembles the previous examples here where we have odd degrees and they ended up in opposite directions. Okay. All right, so now let's talk a little bit about this table. So this table is broken down into identifying what an even degree would be and what an odd degree would be. Not only that, they also talk about the leading coefficient. So if you don't remember what leading coefficient is, let's talk about different polynomial expressions here, right? So the leading coefficient is the coefficient of the term that has the highest exponent. So in this equation, the leading coefficient here is -4 because x to the third power is the highest exponent of this polynomial. All right, so they're going to start talking about the leading coefficient being positive and the leading coefficient being negative. Okay, so again, this is even degree. All right, what happens when it's an even degree and what happens when it's an odd degree. And then on this side is what happens if the leading coefficient is positive, and on this side is what happens if the leading coefficient is negative. All right, and to read this, this is the left end of the graph, and this is the right end of the graph. All right, again, this is the left end of the graph, and this is the right end of the graph. All right, so let's talk about even degree polynomial. So even degree polynomial, if you remember, these are the cases where you have even degrees, even exponents. Okay, so these were my first examples. So if my leading coefficient is positive, on the left side it'll increase, and on the right side it will also increase. So that means that it's like going this way. Okay, they're ending up upwards. Okay. However, if the leading coefficient is negative, then the left side of the graph will decrease and the right side of the graph will also decrease. So that means the graph will go somewhat like this, kind of like pointing down. Okay. Now, if the odd degree, if the degree is odd, so again, my examples are x to the first power, x to the third power, x to the fifth power, and so on, right? So this is when your end behavior, one is decreasing and one is increasing. Okay, so if the leading coefficient is positive, so much like this is positive, and this is positive, then on the left side it'll decrease, so somewhat like that, and then on the right side it'll increase, so something like this. Right, so they're ending up in two different directions. One is going down on the left side, and then the other one's going up on the right side. Okay, so now if the leading coefficient is negative, for example, if that was a negative x cubed, then on the left side it'll be increasing, so something like this, and on the right side it'll be decreasing, right? So obviously we don't know anything that's going on in the middle. This is just an approximation, and again, this video is to show you specifically the definition of end behavior, okay? All right, so let's practice with these graphs, okay? So this graph right here, I've explained earlier that this end behavior is decreasing on the left side and it's increasing on the right side. So because of the fact that they are going in opposite directions, then you must have an odd degree polynomial here, okay? Not only that, we can also assume that if it's decreasing on the left and increasing on the right, we can assume that the leading coefficient is positive, okay? All right, so um, let's take a look at some more examples. So again, this graph seems like on the left end, it is going up, right? Going all the way up, and then on the right end, it's decreasing, going down. So again, because they're going opposite ways, we can identify that the degree is odd. And because on the left side it's increasing and on the right side it's decreasing, we can say this one has a negative leading. I'm just going to say lead, and I'm just going to abbreviate coefficient. Okay, let's take a look at two more graphs. All right, so here we have this graph. Okay, so we just want to focus on end behavior. So the end behavior here is up, both up. All right, so we can identify that the graph is an even degree. And because they're both pointing upwards, or they are increasing on both ends of the graph or both sides of the graph, then we can identify that it has a positive leading coefficient. Okay. All right, now here we have identified that the end behavior here are both pointing down. So if they're going in the same direction, again, they are even degree. And it has a negative leading coefficient because of the fact that both ends are decreasing. All right. Okay, so now let's talk about how to write and describe the end behavior properly. All right, so here we want to use this language right here. Okay, so we want to use the following words. So as x, arrow means approaches, positive infinity, that means the right side. So on the right side, this end behavior is going to positive infinity. It's increasing, okay? F of x is going to positive infinity. That means it's increasing on the right side. Okay? And then on the left side, so as x approaches negative infinity, f of x is approaching negative infinity. So that means it's decreasing on the left side. Okay, now what about this one? I'm going to switch colors here. So this one, as x approaches positive infinity, so the right side, f of x is approaching negative infinity because it's decreasing on the right side. Okay, now as x approaches negative infinity, which means the left side, f of x is approaching positive infinity, meaning it's increasing on the left side. All right, let's take a look at, so again, that's how you would describe the end behavior. So let's take a look at our even degree here, okay? All right, so we know that if it's an even degree, both, and it's a positive leading coefficient, both of them are increasing. So this would be relatively easy to describe. So as x goes to positive infinity, you can also start with negative infinity as well, right? So as x approaches positive infinity, which means the right side, f of x is approaching positive infinity because it's increasing, okay? As x approaches negative infinity, which means the left side, f of x is also approaching positive infinity because it's also increasing on the left side. Okay, I'm going to switch colors again. So I'm going to make it green. So here, even degree and negative leading coefficient, both of them are decreasing. So again, relatively easy to describe. So as x approaches positive infinity, meaning the right side, f of x is approaching negative infinity, meaning the graph was decreasing on the right side. And as x approaches negative infinity, f of x goes to negative infinity. Again, the graph is decreasing. All right, so that's how you would describe it using that language. Okay, let's take a look at our last example. So our last example, we're not given graphs, but rather we're given polynomial expressions. So what I would like to do is I would like to describe what the end behavior looks like by identifying the degree, the leading coefficient, and writing it out, okay? So here, we know that the leading coefficient, so I'm going to say LC for leading coefficient, all right, is negative. And we know the degree, so I'm going to label it D, is odd, okay? So if I know that the degree is odd, I know they're going to go opposite ways. And I know that if it's negative, then it's somewhat going to be like this, where on the left side, it's increasing, and on the right side, it's decreasing. Okay, so without even graphing this, I know that my end behavior is going to be increasing on the left side and then decreasing on the right side. So as x approaches positive infinity, f of x, so again, this is the right side, f of x is decreasing, so we want to say that's going to negative infinity. As x goes to negative infinity, the left side of the graph, f of x is approaching positive infinity, meaning that it is increasing on the left side. Okay, let us switch colors and let's go to the next example. X to the 6th minus 7x to the 5th plus x to the 3rd, that's supposed to be to the 3rd, minus 2. Let's fix it. Okay, so that there's no confusion. Okay, so now let's do this over. So the leading coefficient here is 1, okay, and that's positive. And the degree here is even, okay, the degree is 6. And I just want to point out that even if this x to the 6th power was all the way at the end, the leading coefficient does not change. It does not become any of these. It's still x to the 6th. This is the term that you want to look at because it has the highest power out of all the polynomial terms. So the degree here is 6, which means that it's even. Okay, and now if we have an even degree, we know that it's going to point in the same direction. If the leading coefficient is positive, we know that direction is going to be upward. All right, so as x approaches positive infinity, f of x is going to increase. As x approaches negative infinity, f of x is going to also increase. All right, we're moving forward. Okay, so now here we have another expression, 2x to the fifth plus 3x squared minus 4x minus 1. So this time I'm going to label the degree first and then my leading coefficient. All right, so we're looking at the highest exponent, which is 5. 5 is an odd number. All right, so that's an odd degree. The leading coefficient of x to the fifth is 2, and 2 is positive. Okay, so now I know that if it's odd, then my endpoints are going to be going in different directions, and I know if it's positive, then it's going to somewhat increase on the right side and then decrease on the left side, okay? So as x approaches the right side, positive infinity, f of x is going to increase. All right, as x approaches the left side, then f of x is going to decrease, all right, marked by negative infinity. Okay, let's move forward. Our last example. Okay, so we have negative 3x squared plus x plus 1. All right, so let's start with the degree and then the leading coefficient. So the degree here is 2 because it has the highest exponent, and it's even. Okay, and then the leading coefficient is negative. All right, so I know that if it's even, they're going to go in the same direction. And I know if it's negative, they're both going to decrease. Okay? All right, so we have as x approaches positive infinity, that means the right side, f of x is going to negative infinity, meaning it's decreasing. All right, so as x approaches the left side, f of x is also decreasing. Okay, and that is end behavior. Thank you very much for watching that video.